Hi again, everybody. Welcome back. We're going through chapter 10.3 homework, and I'm actually walking you through all these problems right here. So, the last video segment we had just done problem 5. This one's number 6. It's also partially why it's all the way at the very top of the screen right there, because if I scroll down, you'll see the writing from 5. Actually, it probably doesn't really matter. We're going to have plenty of room right here, okay? So this is a problem a lot like the bullet and the rifle problem from the previous one. Okay, we have two objects. In this case, they're people, ice skaters, who are at rest, but then they push off each other. All right, one person pushes on the other person, and that person pushes on the first person, just like between a bullet and a gun. Well, the bullet doesn't do the pushing off, but the gunpowder does. It pushes on the bullet and on the gun. So just like with the ice skaters right here, they both experience that same force. Okay, now I'm going to call this person the first person, person 1. So the mass of 1 equals 45 kilograms. All right, let's go ahead and write that. Um, So, and actually, let's draw them right here. So they're standing here. They got their hands out like that, and that's their head right there. Pretty horrible. And this person right here is also on ice skates, and they have their hand out as well. And there's their ice skates right there. Okay. So they're going to push off. But what is their initial momentum of that system? Well, it's 0, right? Because neither of them is moving. And you know that momentum is mass times velocity. So if they have, neither of them has any velocity, the initial momentum of the system is 0. But since momentum is conserved, we can say, I should put an I there for initial. The momentum of the system final also has to be 0, because before and after any collision, the momentum of the whole system is always the same. All right, but we're getting ahead of ourselves right here. We've written down the mass for the first person. Um, the final velocity. Well, first of all, the initial velocity of 1 is 0, right? Initial velocity of person 2 equals 0, because they're sitting still. The final velocity of person 1 equals 0.62 meters per second. The final velocity of person 2, that's this person over here, the other skater, we'll say, is 0.89 meters per second. And what we want to find out is, what is this second skater's mass? So this is person 2 right here. We're gonna do it, right? So mass 2 is, that's the big question mark. Okay? Well, once again, we can say that the total initial momentum of the whole system is 0, and that's going to be equal to the net momentum final of the system. All right, so 0 equals, what's the final momentum of the system? Well, that's going to be momentum of person 1 plus the momentum of person, I don't know what that is right there, person 2. Okay? So the final momentum has to add up to 0, because the initial, we know the initial momentum of the system is 0. Okay? Well, let's expand these out. All right, we can know that momentum is 0 equals mass 1, velocity final 1. Now remember, on this side is all initial, and this side is all final, because we're comparing initial and final. Plus the mass of person 2 times the final velocity of person 2. And we're solving for the mass of person 2 right here. So let's get everything else away from that side by subtracting over m1 v final 1. So negative m1 v final 1 equals m2 v final 2. All right? We're still solving for m2 right here. Okay. So let's divide down our v final 2. All right, so negative mass 1 v final 1. By the way, I should call this, let's see, I'm going to call this direction, well, no. First of all, I'm going to call this person 1, and this person 2 right there. And 1 is going in the positive direction, 2 is going in the negative direction. Okay? I guess I should have specified that right there. All right? Establish your directions, which one is positive, which one is negative. Okay, we're solving for this mass 2, so we're going to divide down V final 2. V final 2, right? Equals mass 2. All right, now look at this for a second. No matter what these values are right here, mass 2 is going to be negative. What? Can we have a negative mass? No, we can't. Mass can't be positive or negative. So what's the deal here? What did we miss? Well, we said that the speed of the one person, this person shooting this way, is 0.62 meters per second. And then we said the other person going the opposite way, this way, is 0.89 meters per second. That is definitely their speed, because speed doesn't account for direction. But velocity, if you say the velocity of person 2, what's it going to be? Well, velocity does account for a direction, and the velocity has to be in negative. Negative 0.89 right there. So that's why I drew that in red. So that's what accounts for the negative right here. So we're going to be dividing by a negative number, which means everything will work out. All right, so negative. Oops, I'm writing in red now. Let's do that in blue. Negative, what's the mass 1 right there? That's 45 kilograms, right? Okay, times the final velocity of person 1. That is 0.62 meters per second. Now divide that by the negative 0.89. That's going to give us a positive value for the mass of person 2, and it will tell us what it is. So 45 times 0.62, and divide that by 0.89, or you can put all the negatives in, but you know the negatives are going to cancel out. That is 31.3 kilograms, and that is the mass of person 2. All right, we did the same thing we did with the bullet and with the rifle. Initial momentum of the system is 0. Final momentum of the system is still 0. That's because we're accounting for positive and negative directions, when dealing with momentum, they're going to cancel out and be the exact same momentum as it was before the push-off. Okay? So that's it for this example, or well, this problem. Problem 6 from Homework 10.3. Thanks for following along. I'll see you on the next one.